If you've ever found yourself on a big AV job, I'm talking a camera way behind a football goal or a feed across a huge convention hall, you know the real enemy is just cables.
It's the cable spaghetti.
Exactly. You've got one for video, another for control, one for power. It's a mess. So today, our mission is a deep dive into the Datavideo HBT-12 HDBaseT receiver box. This thing promises to fix all of that.
It really does. And it all comes down to one standard, HDBaseT. For you listening, think of HDBaseT as the technology that lets us, bundle all those different signals, video, data, even power onto a single standard Ethernet cable.
Right, turning that multi-cable mess into just one clean run.
Well, one high-speed conduit. That's a huge step towards simplicity.
So that's the synergy, that unified conduit. And the key here is it uses a single Cat7 cable, right? That's what's recommended for the best distance.
That's the one.
So what exactly is traveling down that one little cable? It can't just be video.
No, and that's what's so fascinating. You've obviously got your HDMI video and audio, but then they've layered in all the control protocols. So it handles DVI-P, which is their modern IP-based camera control language, and it also manages the older, mission-critical stuff like RS-422 and RS-232.
Ah, so it's not just about a clean signal. It's about backward compatibility. You could use this to talk to a brand new PTZ camera, and at the same time, control a $1 million broadcast camera that still uses the old RS standards.
All through the same wire. That flexibility is, it's massive. It changes your entire deployment schedule.
But the real trick, you said, is power.
The real kicker is the power. Yeah, they do this very clever thing with PoE++ offset or power over Ethernet++.
Okay, wait, let's unpack that. Because usually power runs to the device. How does this work?
Well, it's kind of inverted. You plug the main 56-volt power supply into the HBT-12 receiver, which is usually at your end in the studio rack.
Right, at the hub.
Exactly. And then the receiver itself becomes the power station. It sends up to 65 watts of power, back up the Ethernet cable to the transmitter, the camera, the encoder, whatever's out in the field.
So no need for a power outlet 100 meters away.
None at all.
Sending 65 watts plus all those signals down one line, that requires some serious signal integrity. We're talking long-distance 4K, right?
We are. The receiver accepts high-quality 4K by 2K video. So think 3840 by 2160p at up to 30 frames per second. But, your distance depends on the resolution you're pushing.
Okay, so give us the breakdown. On that Cat7 cable, what are the limits?
For standard HD, so 1080p at 60 frames, you're looking at a solid 100 meters, which is a huge run for an auditorium or something.
Yeah, that's pretty far.
But if you jump to full 4K, the physics of it brings you down to 70 meters, which is still, incredibly respectable. The overall max they note is about 120 meters.
And to handle those kinds of deployments, I imagine the box itself has to be pretty tough.
Oh, it does. The documentation really emphasizes this heavy-duty aluminum alloy housing. It's rugged, but the key design feature is low heat dissipation.
Why is that so important?
Well, for long-hour operations, you need reliability. But more importantly, if you have to stick this thing in a sealed, unventilated box outdoors to protect it from the rain, it won't cook itself.
Right, which is a very real-world problem. So let's bring it all together. What does this all mean? We have a box that takes 5 separate things: video, audio, 3 different kinds of control, and power, and puts it all on one simple Ethernet line.
It just removes cable management as a major barrier. You run one cable, you plug it in, and your entire camera system is online.
So here's a final thought. If you can eliminate 4 out of 5 wires and power the device remotely, how does this level of consolidation fundamentally change how we design remote live production sites, especially those that have to operate in the absolute roughest conditions? Do we stop thinking about complex wiring and start focusing more on just building compact, passively cooled junction points?
That's a great question.
Something for you all to think about. We'll see you on the next deep dive.